Hi everyone, welcome back to Digital Dynamo Lab. In our last video, we learned about different number systems like binary, octal, decimal and hexadecimal. Today, we are going to focus on one of the most important concepts, binary to decimal conversion. Since computers use binary numbers, it's important for us to know how to convert those zeros and ones into decimal numbers that we use in everyday life. Let's dive in and understand this step by step. In this video, we will learn two important conversions. First, how to convert a normal binary number into its decimal form. Second, how to convert a fractional binary number, which has both whole and decimal parts, into its decimal equivalent. By the end of this video, you will be able to easily convert any binary number into decimal using simple steps. This table shows how binary numbers are converted into decimal numbers and vice versa. Binary numbers are made up of only zeros and ones, while decimal numbers are the ones we use in daily life from 0 to 9. For example, binary 0 is decimal 0, binary 1 is decimal 1. Binary 10 equals decimal 2 and binary 11 equals decimal 3. Similarly, binary 100 is decimal 4, binary 101 is decimal 5 and so on. As you can see, each time the binary digits increase, they follow the same sequence as decimal numbers but written in base 2. This helps us clearly understand the relationship between binary and decimal systems. Now we are going to explore how to convert binary number to decimal number. We have this binary number 10110 and we want to convert this binary to decimal. Start by writing the bit position from right to left as powers of 2. 2 to the power of 0, 2 to the power 1, 2 to the power 2, etc. Multiply each binary digit by its place value. 1 into 16, 0 into 8, 1 into 4, 1 into 2, 0 into 1. Then add them up 16 plus 0 plus 4 plus 2 plus 0 equals 22. So 10110 base 2 equals 22 in decimal. Now let's see how to convert the binary number 10110.101 into decimal. First, split it into two parts. The integer part 10110.101 into decimal. First, split into two parts. The integer part 10110 and the fractional part 0.101. Starting with the integer part, we place each digit under powers of 2. That gives us 1 times 16 plus 0 times 8 plus 1 times 4 plus 1 times 2 plus 0 times 1. Adding these together equals 22. Next, for the fractional part, 0.101. We use negative powers of 2. So we have 1 times 1 half plus 0 times 1 quarter plus 1 times 1 eighth. That gives us 0.5 plus 0 plus 0.125, which equals 0.625. Finally, we add both parts 22 plus 0.625 equals 22.625. So the binary number 10110.101 is equal to 22.625 in decimal.